Today's lesson is in reference to 7.1 in our stats book, and it's called 7.1 Sampling Distribution of the Sample Mean. And we're starting with an introductory penny activity related to the dates on all of these different 25 pennies. And this continues the theme of our year in stats, where our aim is to get a clearer and clearer picture of the data for an entire population. Now, today's population is these 25 pennies, and the information, the data that we're looking for, are the dates on these pennies. So this is typically an activity we would do in groups in class. However, I'm going to do it just to show you. I think it's a really valuable activity to introduce this topic of sampling distributions, in particular of the sample mean. So the activity starts where each student on the team pulls 5 samples of size 5. So that would be 25 total pennies. So I'm going to go ahead, and there's a sample of size 5, another sample of size 5, a third sample of size 5, a fourth sample of size 5, and our last sample of size 5. So I have 5 samples of size 5. Again, if you were in a team, you would each be taking this amount. Next is each student writes out each penny date for each of your 5 samples, and then find the sample mean for each sample. We'll round to the nearest year. So I'm going to take a look. I'm going to trade this one out. It looks like a penny from a different country there. We're going to start with this group right here. We have, oh my, that one's been through it. So we have, let's put these aside for the moment. We have this 1964 penny, followed by the 2019, 2018, 2011, and let's see here, 19, that's tough to read, 88. So we're going to add those together, divide by 5, 1964, 2019, 2018, 2011, and 1988. Add those together, double check, make sure they look good, and divide by 5, and we get 2,000. So the average, so then X bar would be 2,000. And then it says each student marks their sample means on each of the other students. Oh, sorry, I skipped step 3. Each student chooses a unique color to mark your dots along your horizontal axis. So that would constitute 2,000. 1 dot. So this is unique from what we've done in the past, where each one of these different dates would be its own dot, and we would look for a sampling distribution of individual data points. Now we're looking for a distribution of sample means made up of a variety of means of a variety of different sizes. So 2,000 would be right here. So I'm going to put my dot right there above 2,000. Now I'll repeat this 4 more times. Put that sample aside. Look at each penny. you can see I have a 2016, 2019, 2017, another 2019, and it looks like a 1950. All right. So we can go ahead, same process. Add those together, divide by 5. Let's get there. So it's 2004.2, so we'll round that to the nearest year, which is 2004. So we'll put a dot on the dot plot, 2004 here. And move on to our next set of 5. Oh, these are harder to read than others. So 2018, I believe that's 1993. Yep, 1993. 2016, 2000, and 2007. Our average here being 2006.8, we'll round to 2007. We'll do this 2 more times. $1964. 1988, 1976, 2018, and 2001. Oh, I forgot to put my 2007 dot here. So we'll add up this 4th sample, 1964 and 1988, 1976, 2018, 2001, divided by 5, we get 1989. So that is rounded to, is 0.4. 1989 would be the, how we would round that. 1989. It's our lowest so far. One more. So, sample 5. If you watch the introductory video here, you'll find out that some of these pennies are worth more than others. In fact, all of these pennies are more valuable than 1 cent. It costs, I think, 1.6 cents to produce 1 penny. 1982 and 2018. So 1967, 2016, 1983, 1982, 2018, divided by 5 gives us 1993. So X bar is 1993. You can see we've got a great spread here And you can imagine if there were 5 individuals doing this same process, that we would end up with a more significant number of dots here. Obviously, 25 dots if there are 5 students per team. And then our dot plot would start to look a little bit different. Next is round 2, and we're going to repeat the same process as round 1. And these samples will include 10 pennies each, size 10. So n equals 10. So each student again would have 50 pennies. And then in round 3, we'll repeat round 1, only this time each student will have samples of size 25. Now each student would calculate just 3 samples of size 25. That takes a little bit longer. So we'll see how that plays out. And then finally we'll do a reflection. I'm going to go ahead and pause and fill this in for you so that you can see how things start to play out when we have sampling distributions, and maybe you can start to make a prediction of what you can imagine the sampling distributions will look like as the sample size increases.